Okay, so participant, now we are starting our next session. Uh, Mr. Bhatt is there. Am I audible? Mr. Bhatt, are
Yes,
you there?
yes, yes,
Okay,
I am here.
okay. So please switch on your camera.
Yes, I already did.
Fine.
Yeah.
Yes, yes. Now you are audible and visible also.
Okay, thank you.
Okay.
Very good evening.
So welcome, welcome. So dear participant, now our next session number 12 is going to start, and it is on the again our one of the main pillar of industry 4.0, that is the relative to the additive manufacturing at the scale of micro scale or nano scale. And our distinguished speaker is Mr. J.R. Bhatt. He has done his graduation from with the mechanical engineering and MTech with manufacturing engineering from SVNIT Surat. He is also doing the MBA. He has more than 10 years experience in different front like product development, establishment of various system. He has also served as a academician, and his main skill is DLP, 3D printer development and production planning, product development, additive manufacturing, design and modeling of Inventor, Fusion 360, Solid Edge, SolidWorks and AutoCAD. All this he is familiar with this all soft tools for designing purpose. He has delivered certain services in reverse engineering domain also, as well as the quality assurance committee and cell. With this brief introduction, quickly I would like to hand over the session to Dr. J.R. Bhatt.
Thank you so much,
Bhatt
Dr.
sir, over
Piyush
to
sir.
you.
Yeah, thank you so much, Dr. Piyush sir, for inviting me. Good afternoon, all. I hope earlier session is very informative by Dr. Datta. Now let's jump into in the world of additive manufacturing. I hope all of you may aware about the 3D printing. In your institute also you can find out 3D printer. Okay, and let make this session informative. If you can like provide your answer in chat, it will be very grateful. Okay, I hope my screen is visible to all of you.
Yes, it is visible.
Yes, so as Dr. Piyush sir is explaining, my topic is micro nano additive technology in context of industry 4.0. Myself, Jamin Bhatt, technical engineer at Engineering Technique. Okay, so let's get started. Introduction to micro and nano additive manufacturing technology by Industry 4.0. So may I know what do you mean by Industry 4.0? Can anyone can write? Already, this is the last day and last session, I hope. So you may know about like Industry 4.0 may include control system, instrument, sensors, some internet connection available with some robots are involved, some human machine interface is there. So we can call this as a Industry 4.0. And just like overview about the micro nano machining and Industry 4.0. So in nowadays, micro nano machining techniques like ECM, electrochemical machining, electro discharge machining, laser beam machining, ultrasonic, and one of the famous femtosecond laser, which provide precise and micro nanoscale fabrication. And with Industry 4.0 integration, we can achieve cyber physical system, artificial intelligence, automation, enhanced precision, scalability, and efficiency in manufacturing. With Industry 4.0, we are also take adaptive control and predictive maintenance we can do for our manufacturing and production systems at micro and nano fabrication level. And also application include biomedical devices, photonics, MEMS, micro electro mechanical systems, and nano electromechanical systems. Ahead, I will discuss the DLP chip, which is widely used in 3D printing technology called as DLP, digital light processing. So we will see application of MEMS and NEMS in that. And also high density electronics manufacturing also, we will look into it. Okay, so this is only overview of the micro nano machining process available. What are the research and technological advancement done in this area? So advanced laser surface texturing method is obtained by multi-beam LST, laser surface texturing, which can control infrared control, enables faster scanning and enhance surface feature for micro machining. Another research and development is done in MEMS device fabrication is femtosecond laser, which create nanoscale structure on silicon carbide and advanced materials. Also, we can combine that femtosecond lasers with water jet and chemical etching process to enhance our precision manufacturing or machining capability. Okay, and with help of simulation and Industry 4.0, we can perform finite element analysis and molecular dynamic optimize micro and nano machining process. So this is very informative side if you want to know about the femtosecond laser processing. On the left side, you may find out normal laser process we are doing. Okay. What is the full form of laser? I hope all you may aware. We can relate it with our students. Okay. Light amplification by stimulated emission of radiation. Whenever in industry, we are getting student for industry visit, I just use the example like student, as a student in student life, we are behaving like a laser. If we get higher rank, then we are getting excited. But the excitement stage is not permanent in nature. So we will come back to our original position. That is only laser part. Okay, light amplification by stimulated emission of radiation. So in normal case, we are providing long pulse duration to do machining like drilling process, in which larger heat affected zone is created, more debris is created. It will going to damage our part. Instead of providing long pulse duration, if we provide laser with short pulse duration, how much short pulse duration? 10 raised to minus 15 second, which called as femto. Then what will happen? Small heat affected zone will create and you will find precision machining, which can be like achieve in 30 micron area. Okay, so nowadays femtosecond laser processing technology is combining with the other technology like water jet, ECM, EDM. So we can perform micro and nano scale machining. Then if we want to talk about the additive manufacturing, which is generally called as 3D printing, layer by layer technology, rapid prototyping and tooling. In almost all the university nowadays, there is a subject called rapid prototyping or rapid prototyping and tooling. Okay, so major leader which we are representing at engineering technique is Enuzen Tech and Desktop Metal, and some other leaders we know as we are in this additive manufacturing field, Nano Dimension and Visitech. Visitech is enabling 3D printing technology. They are providing some critical parts which are used in 3D printing processes. Okay, so let's discuss it one by one. Now, what is DLP? DLP means digital light processing. Whatever input or whatever image we are getting, we need to process it with help of digital light processing unit. So generally, right hand side image is showing, which is the example of MEMS, NEMS, micro electromechanical system or nano electromechanical system. Whatever tiny square you are seeing is micromirrors. Micromirrors produced by Texas Instruments. That micromirrors are known as DLP chip. In market, 0.47 inch DLP chip is available. 1 inch DLP chip is available. That chip is using, we are using as an industry in various technology. Okay, so whatever light source will provide the input image, that input image will process by the DLP chip. Here also mention million of microscopic mirrors which are individually controlled to produce clear and crisp images. And each mirror controls a pixel that can either on or off or some value in between, what we called as grayscale. Okay, so how DLP printing works? This is the basic schematic available in front of you. Okay, so what will happen below the machine? What we have one projector. We can call it as industrial UV projector. Okay, inside which like light source is coming with help of UV LED. There are some precision optics available, which is like mounted steadily. There will be no movement of it. Whatever UV light is generated from bottom, okay, which is transferred to the DLP chip, which is made out of million of micromirrors, and then projected through the lens, series of lens available with the various focus level to get image in this particular material tray. Inside the material tray, you will find photopolymer. Photopolymer is nothing but the liquid polymer resin, which can be like cured with help of photon energy or photon light. Okay, and there is the build platform is available, which will reciprocate like coming at down and up during the process. And image is continuously we are projecting one by one. So this is the DLP process. In general, we can say DLP printer or DLP 3D printer can work. Okay, and various materials are available. Photopolymer resins are available or material available for various applications. Like if you are able to see this small ring in end of mine, or this Ganpati ji, Lord Ganesha is, these all are printed in DLP 3D printer. Okay, we can also, like, if you can search out, or if you looking to buy any jewelry nowadays, gold prices are so much high, like cross the 1 lakh rupees. That's why government of India recognize 9 carat gold, and also like enable BIS marking. Okay, so first application of DLP technology, you can say, is jewelry. This is the machine by Envision Tech ETC. Okay, and machine name is D4K Pro, which can process more than 100 materials available in the market. Okay, whatever fine designs you are able to see, which is printed in WIC 100 material. Sorry. So that WIC 100 material, which contain 10% wax inside it. And if you know about vacuum casting process of the jewelry, or vacuum casting process we studied, or you are teaching for so many years for engine production, or high accuracy, high surface finishing casting part you are teaching. Okay, that vacuum casting process adapt these designs directly in the process, and this particular rings will get sacrificed during burnout cycle and create negative impression in the mold for our precious metals like gold, silver, whatever gold color you want to take. You can add alloy accordingly in your mixers. Okay, for example, if you require white gold jewelry, you require rose gold jewelry, pink gold jewelry, or yellow gold jewelry, you can get it. So this is the DLP technology based Envision Tech D4K Pro. What is 4K? 4K is the technology. Inside this machine, 4K technology DLP chip is installed. So whatever image we are getting from the machine, it possesses the 4K technology or 4K resolution. So you can see the clarity of the design. Okay, these prawns are 0.4 mm. Some filigree work or turkey designs 150 micron we are producing. And if we are taking, if you want to know accuracy of this machine, you can achieve 00. Or in general, we are saying plus or minus 25 micron accuracy you can achieve. But Envision Tech is guarantee, or we also calibrated this machine up to 00. Means if you want to print 0.1 mm diameter, you can able to print 0.1 mm only. Okay, what we called as 100 micron. So Envision Tech is known for high resolution DLP printing. And we are happy to inform you, like, if you don't know, Envision Tech is father of DLP 3D printing. With help of Texas Instrument DLP chip, Envision Tech invented DLP 3D printing application in the market. And this DLP 3D printing application you can do in dental, jewelry, and mechanical. Or there is the industry called MCAD, mechanical, electrical CAD solutions. So you can achieve. Okay, also these machines we can call as Industry 4.0 integration. Today, there is off in our industry. Okay, so that's why I'm unable to connect with our machines. Otherwise, every year we are visiting IIJS, International India Jewelry Show in Mumbai. So whenever what is the control software, it is available with me only in my laptop because I am technical engineer of the Envision Tech in engineering technique. So if any urgent print required to put in this particular D4K Pro, okay, we have this D4K Pro in our premises in Vadodara. So what I did, I prepared the job file. I ask my team member, I connect with our server through VPN. Once I will connect with VPN, with help of VPN to our company's server, I can access printer from my laptop. I can able to see human interface of machine on my laptop screen. Okay. There is no camera inbuilt inside the machine. If camera is inbuilt, then maybe I don't require any physical attention. So nowadays, like now time, it is not attached in the machine. I require one of my colleagues' help to check whether platform is in place, material is inside the material tray. Please stir the material if it is inside the material tray. Okay, and then I can put a print with my laptop only. I can stop it from my laptop only. Means whatever control I want to perform on my machine, I can do. Whether I am sitting in my office, whether I am sitting across the globe, where internet is coming. Okay, so you can provide, like you can print. For example, any electrical or electronics company require casing for their biometrics. They can provide us the design. We are converting into a STL file and printing in these beautiful machines, technological advanced machine. Whatever machine you are seeing, it is a Pro Excel. Okay, DLP technology. If we are talking about additive manufacturing, it is generating waste, but which is minimal in the nature. Whatever support is required in hanging part, that is required, and that is the waste only. Okay, but some rings can be made without support also. Okay, and now whatever I am showing you, it is like advanced machine of the Envision Tech, okay, DLP technology base, which can disturb, like change the industry of the foam. Foam we are using widely for car seats, for our bed, for our office chairs. So let's see how what you can get from image, video. So Envisantech is a brand of desktop metal. Earlier it is Envisantech only, but desktop metal acquire it. Okay, so what you get, I hope all of you get the idea of foam industry. We cannot get our own design foam for our bed seat, for our car cushion, for office chair. We require that solid block only. But free foam is the material developed by Desktop Metal and Adaptive 3D company. Okay, so what can I say? If I am exporter, because nowadays Make in India wave is happening and we are manufacturing whatever earlier we are not manufacturing. So if I'm manufacturing shoes, for example, okay, so with help of this technology, DLP technology, Extreme 8K machine, and this freeform material, we can print 10 number, 11 number shoe size sole as shown in the video. Okay. In which size we are going to print it? For example, my shoe size is 11 number. I will print shoe of my size in size of my baby, my son. Okay. And then I will ship it to reduce my shipping cost. And at US or Europe facility, customer hai or I have my own setup of curing machine. Whatever curing require, you are showing in the video. Okay. So when they are going to cure it, it will convert it automatically into 10 or 11 number. This material can expand up to 2x to 7x. Okay, so in 3D printing, there are materials are available which can like provide drastic change in the industry. Then if we talk about the electronics, then you need to know must nano dimension, which invent additively manufacturing electronics. Whatever circuits we are building for various application like heating application, data transmission application, whatever application, PCBs or circuit we are manufacturing, do you think it is printed with the help of 3D printing? This company made it possible. Okay, Nano Dimension use 3D printing technology which can create functional printed circuit boards or radio frequency circuit with precision and efficiency. They also integration of the SMT, whatever component, surface mount technology, whatever diodes, circuits, SMD things are available in electronics nowadays for soldering, for which reverse flow soldering technologies people are using. But that technology is not available in many industries also and not in academic as for as per my knowledge. Some university may have that technology. Okay. So nano dimension provide the integration of surface mount technology also with additive manufacturing, which like we can say provide the higher production rate for electronics production and provide minimal environmental impact. And also this technology are driven by the artificial intelligence for autonomous production. Okay, like intelligent logistic is used, high speed dispensing, autonomous electronics production, whatever gel or material we need to provide for reverse flow soldering, that provided by the autonomous AI driven technology. Okay, and application industry 4.0 alignment also done for various application for aerospace, defense, space missions, while what supporting the rapid design interest. What you can say, there are, if you want to develop your part for higher production people are using injection molding technology, but injection molding technology will cost you around 3 lakh 4 lakh rupees, also require almost 1 month production schedule, like tooling production it will require. Okay, then if you know about the urethane casting or vacuum casting for plastic parts, which is called as polyurethane casting, so that is also like taking 20 days to 30 days production, like to produce the part or tool for your application. So 3D printing is widely used for faster production also and faster prototyping also. So now take a look of the video of Nano Insights. Okay, so what you get from this particular video? You may know about like entire product offering of Nano Dimension, also the collaboration with the GEMS, which is like providing the community for electronics or electrical engineers who want to build their own design circuit boards. Okay, so nowadays this technology must be passed to our like Indian students. That's why I feel like to show you, to aware you all about this. Now, in between, if I want to show you what is the output, we are talking about the DLP technology, DLP technology. Okay, but everyone is talking about what is 3D printer applications they are showing. Now I am showing what input we are giving to the DLP printer. Okay, so there is the slicer available, specific slicer. If we add our designs STL file into it, okay, if we select material is select right now, it is offline mode because today is off. We can select the material which we want to print. We can achieve like whatever layer thickness required in our part, we can achieve it like 25 micron, 50 micron, 35 micron, whatsoever. Okay. And if we load here any STL file, you will get such type of folder. What is inside this folder? You will get some previews, whatever files you added in the platform. Okay. So that frames are available in various angles. Other thing is like notepad file to read by the machine to perform the job. Okay, if you want to see the languages also, you can see here some encryption is done and like image tagging is done. Image 002 up to whatever slicing image with whatever layer thickness we slice it. So almost 1265 images are stored and command is given. Here some section parameters is given in coding like layer 001, part 001. You need to perform the like instruction for the machine to perform the job. Other job info is there because what is inside the like what machine DLP machine can do. DLP machine can project the images like a projector. Like right now I am presenting. Right now I am presenting different slides in front of you. Okay, so similarly, DLP in DLP 3D printing technology, DLP projector is there with UV light source. So it will project the images, whatever images we are providing as an input. Okay, so there is some UV power inside it, which will cure photopolymer, which we are locating the material tray. Okay, I earlier saw in the slides. Also, you can able to see some ultraviolet image during the video of the Extreme 8K freeform material. So there are some velocities required. Okay, separation velocity is required. Projection exposure time is required. Waiting time is required. Exposure time is required to expose the image, project the image. Waiting time required whenever my platform goes up and go down again. Why upward movement is required? because there's the bottom layer printing happen there. We require next layer, we require recoating of our material, liquid material on our printed part. So that will convert it into solid once projection of image is done. Okay, so for that recoating purpose, we are going up and we are coming down. We are going up and we are coming down in every step. So waiting time is required. And that movement is done partially low velocity, then fast, high velocity. If we want to move up platform by 5 mm, 2 mm will be done with slow velocity, 3 mm will be done with the high velocity. So all that parameter is defined. You can find it here, the value. Okay, distance is given. So all that parameter is, this is the data processing. Envision Tech machines are security, like security base also. There is one RFID card on the top of the machine. If you remove it, your print will get stopped at a time. Okay, like all the machines, Envision Tech machines are manufactured in Germany and they are closed loop. You cannot use third party material. So they are providing material type and with the RFID code also. And also all the information available, scene dimension, whatever you are able to see here, that dimensions are given. Model processing data is given, like whatever file name we are loading on the platform, it is showing. Okay, which slicing software used, so Envision 1 RP is used, such information will be provided. And then series of images. These are the images will be projected by the DLP printer. I hope you can get very much inside of it. Now, at pixel rate, if we can say what will be inside the micro or nano scale, you will find out. Into pixel by pixel, you will find out these pixel units. Okay, this is nothing but job inspector. Whatever slicing images you have, if you load that folder in this particular software, you can inspect it. I hope you are getting changes. You are notice changes in the images. Okay, so now if you zoom it out, you will find out some, you can say, Envision Tech introduce layer shifting technology. Okay, this is the part inside which boundary you will find out some pixel with some lower intensity. Here you will find out intensity 100%. Section number 212 and pixel location is located 1361, X and Y is 640. Okay, if you move ahead, it is also showing intensity 100%. But if you move to extreme part, you will find out intensity is dropping by 89.02%. Intensity is dropping by, and now available as 45.88. And here 18.82. So it is called as pixel shifting. In 3D printing, I hope if you go through it or if you are teaching, in your curriculums. You may know about adaptive slicing and uniform slicing in 3D printing. Okay, so this is not directly related to the adaptive slicing, but it is a pixel shifting technology. How? Here you can see every layer have this particular pixel difference, intensity difference. Generally, what will happen in every technology, DLP technology, SLA technology, LCD technology, FDM is technology, fused deposition modeling. I hope nowadays every university or every colleges, engineering or diploma colleges or even ITI colleges have 3D printer. And most common technology all people have is FDM. So FDM you will find out very moderate surface finish. You can feel by touching any 3D printed, FDM printed part, you feel the surface roughness of it. Okay, you visible if you look at closely with our eyes only, you can find out layer marks. But in DLP technology, you cannot hardly, you can get the layer marks. By loop, you can see it. But if you want to feel it, it will not available due to layer shifting technology. Okay, so what will happen? Material, whatever intensity, like 18.04% intensity is projected, and here 44.31% intensity is projected. So material going to cure here, but cure towards the inner part. And hence it is like reducing the layer marks or layer roughness is whatever surface roughness is created by the layer. Okay, even if you like visiting any whatever small dots you are observing, these all are the supports. So supports also you will get fine in surface. This is this one cylinder in 3D, it is cylinder or circle only in 2D. Okay. Even though they are providing the layer shifting technology to it. If you are if you are aware about the WIPO, World Intellectual Property Organization WIPO, and if you search out WIPO and patent scope, in patent scope search bar, if you type Envision Tech, you will find more than 30-40 patents in name of Envision Tech. Okay, there one patent which only talk about technology of converting 3D file into 4D and then converted into a 2D one. Okay, so in which layer shifting technology patent, like whatever detail is available. Okay, generally in 3D printing technology or in digital light processing, if we are talking about, there is term, you can find it out here inside the bracket 255. 255, if you tell to the DLP 3D printer machine, it will project full white image. And 0 is full dark image. Okay. For example, 82, here if you can look at 32.16%, 82 is written. So means on grayscale, if you search out 82, you will find out whatever shade you are getting, you can find out. Okay, and if you like come below it, unit is 199. So here you can observe the darkness of these two parts. Okay, one have value of 82 and one have 199. So other name is nowadays like patent got expire. So there are many players who is developing DLP machines in the market. We at Engineering Technique also developing our own Jewel 3D DLP technology printer also. Okay, we will look into it. I hope this particular job inspector or whatever I explain, you all get it. Okay, so now jump to our presentation only. Now, if I'm talking about the Visitech, what Visitech is providing lightning or light engine solution to the industry. Light engine is nothing but main heart of the DLP 3D printer. So, what consists in the light engine? Light engine primarily, what is the light source? UV. Based on the application, if you require DLP 3D printer, which can cure photopolymer, okay, so in which UV source will be there. If you want to do sintering, many of you may aware about the SLS or DMLS, selective laser sintering and direct metal laser sintering. With help of laser, we are sinter polymer parts or we are sintering metal parts. We are fusing and then sintering that part to get our 3D output. So whatever light based application you require light engine, that light engine is provided by the Visitech European company. Okay, which can provide high resolution micro 3D printing light engine, provide versatile manufacturing and industry 4.0 integration. So here the Luxa beam lithography system video is available. You will find out various light engine, various lens technology which is used, because in India, if we talk about lens manufacturer, if being industry, if we require different focal length lens, we are unable to get any like manufacturer in India who is performing like who can give us the lens which we require in 3D printing. Okay, so you will find out projector lens manufacturing. Also, you are able to find out DLP application, scanning application, IR application of the light engine in this video.
Jamin sir, sound is there? Is there a sound of video?
Yes, sound of video is there. Music only.
But here it is not audible.
Okay, I will check it. There is no like information is giving in the video.
Okay, it is only for viewing the things.
Yeah,
Na?
viewing
No
purpose
issue.
only.
Because somebody is asking about the sound, so we are answering.
Okay, okay, no problem. So whatever thing you require explanation, I will provide. Okay, so I hope from video perspective or by viewing you may know about some technology. Okay, this is like very common CMM advance for measuring. Okay, then this particular it is a printed part, and here in this particular they are developing the lens. They are setting focus. If we are expanding images or put nearby, can it fettered? Okay, so they're like this is the series of lens are projecting, and this is the controlling measuring is done, whether it is circular or not. This is the difference lens Visitech is providing, lithography solution or light engine solutions. Okay, this is the electronics and this is the DLP chip. They are providing their branding, but they are using Texas Instrument only. Maybe inside it, there is DLP technology. Texas Instrument made chip is available. Okay, and this is like characteristic. There are water cooling projector available. Generally, what happened earlier, like during the invention of this DLP technology, DLP 3D printing technology, or to make light engine, generally air cooling is provided, fan air cooling. But this company is provided water cooling. Also, you can attach liquid cooling, as I mentioned, camera inside it, optical fiber and liquid cooling. Both options are available. Etherport and gigabit Ethernet is available. Light source. Okay, these two easily swap type and go LED अगर आपको जाना है अगर if you require you can do it, or you can get high power ULED or laser whatever you require. Only easily आपको swipe ही करना है इस technology में. And you can get different wavelength 350 which is more UV and 450 it is coming to more visible light. Generally in 3D printing medical application people are using 350, 365, 370 nanometer wavelength which is more UV side wavelength available in the, and in 3D printing we are preferring for jewelry, dental and mechanical applications 385 nanometer and 405 nanometer. Again, 405 is nearer to visible range, and 385, which you can say in UV range. Okay, and this is the application of the printing. What they developed, I will show you our like projector, our printer detail video in upcoming slides. But this particular company provide sliding projector. Generally, what happening in our industry application only for meeting purpose or in academic application, projector is there in advanced classroom. Okay, so we put our projector steady, and whatever slides we are moving it. But here they make such light engine which you can slide it while projecting. Also, you can do autofocus. Okay, so that type of advancement is done in this particular video. Okay, you can do scaling also. As I mentioned, autofocus. Okay, this is another scanning, or you can say quality check process. Particular technology is technology used to print circuit boards, you can say, in designing. So this particular application, the particular lens is developed by the Visitech is used to find out the defects, or you can say quality check, to measure what your output printed. Okay, such type of electronic application you can also use this lithography system by Visitech. Okay, and this is the technology of the measurement techniques in microns: 4.194 micron, 3.735. Okay, digitally you can scan it, whatever printed part you are getting, and you can scan it with such type of systems. Okay, then another technology is available like IR detect image sintering for R&D lab. Okay, particular light engine is used as a SLS application. If you know selective laser sintering, particular light engine is used for. Okay, so see the video. Don't bother about the audio of the, because there is only music only, and short video is available. You can find out this particular projection unit. It is projecting, and below, is there any powder is available? Sintering is done. Okay, with AI camera. If you view polymer chamber with AI camera, sorry, IR camera. Okay, this boat is manufactured by the IR direct image sintering instead of laser. Okay, I hope all of you get it. Now, to know about the desktop metal, which is master in metal 3D printing. Okay, technology is called as binder jet technology. Okay, so I hope you will get it the idea binder jet and desktop metal binder jet, how it is differentiate. Okay, they are providing new metal powder with roller beside it, and also specialized jetting systems available to scan every part. Here, what is done? Metal powder is binding with help of the binder, liquid binder. It is binded. Whatever output we are getting, it is a brown state. Then we need to sinter it to convert it into a metal. Okay, another disruption with technology is the sheet metal. Okay, so now sheet metal is also manufactured with help of 3D printing technology. You can say tool is guided with help of the 3D printer, 3D printing part. Figure 4, it is brand of desktop metal only. Okay, here note. Okay, so like you can get idea of the sheet metal industry. We require punch and die, tooling is required. Okay, but here with this technology, you don't require any tooling, not require any punch, not require any die. Okay, so whatever like we teach clearance to punch and die, one of the like favorite topic in manufacturing. Okay, people are almost many of your students get confused in that question. In what case, in which clearance is given? Okay, punching and blanking. So here you can get very robust, like whatever design in sheet metal you require, what kind of forming you want, you can get it. If you observe, one part is made in just 30 minutes. Okay, and then like we talk about, like you may get something about like all the technologies developed by the foreign industry, foreign, but we also develop our DLP machine, which is currently available in Jewel 3D, and also for mechanical and dental application also. Okay, so look at the short video of it. This is our machine. This is the X-ray of the machine, material tray, platform. And this is the curing unit. So these three are our products initially for jewelry field. Okay, this is the curing works. Whatever 3D printing, DLP printing is happen with the photopolymer, they are not fully cured. We just cured as it is getting any foam. Okay, structure is generated. We are curing at that level only. But after it, we require curing. So UV curing options is also provided by us. Curing solution is provided by us only. Okay, then what advanced manufacturing demonstration, providing demonstration. So whatever complex part creation, which is not possible by any process, 3D printing will be useful. Okay, we can connect it with Industry 4.0 with help of Raspberry Pi, with help of internet, with help of sensors, camera, and HMI also. Okay, you whatever part you require, like if you require flame retardation, enable material, you will get electrostatic protection if you require in your product. 3D printing provides the solution. If you require temperature sustainability up to 450-degree, 3D printing will provide. Okay. So if we talk about the research and patent about for micro machining and ASME journals, we can find out micro and nano machining techniques to fabricate the brain electrodes and minimizing the tissue damage. You can also get femtosecond laser processing application on silicon carbide for MEMS application, micro electromechanical systems, and photolithography improvements. Okay, with the help of Fresnel lens profile, we can increase fabrication accuracy. And if we talk about the Industry 5.0, where human machine collaboration will be there, and whatever like tedious work, hazardous work performed by the human nowadays in industry, still in the industry, which can be overcome by Industry 5.0. Okay, enhance the work experience. Wherever cobots will handle physical demanding tasks and like providing the human to focus on the problem solving, innovation and technology. Okay, so real our human work will be done whenever Industry 4.5.0 will be introduced. Okay, what are the conclusion and future directions? So Industry 4.0 more transformation is required to transform in micro and nano machining for improved precision and scalability. Innovative and research application is required, like in biomedical field, aerospace and electronics. Already bio 3D printer is available. Okay, we are representing Envisantech bioprinter also. And at engineering technique, we are representing OI Bioscience, which is made in India, bioprinters. Okay, and future trend will be Industry 5.0, where hybrid system, AI enhanced, controlled, and human centric, resilient, and sustainable manufacturing will be focused in our future. Okay, so thank you so much from my side. And you can contact me on my email ID or my mobile if you require any help required from engineering technique. Thank you so much.
Okay, thank you. Thank you, Jamin sir. Now we are opening the session for the question answers. Participant, now you are free to ask the questions. In between also you was, but nobody has asked. So now I hope some doubts may be there among you, so you can clear it. Two way is there. Either you can write in your chat box. Better you write first in chat box, and then if it is need is there, we can unmute you also.
Is there any questions? Or 3D printing or additive manufacturing will be?
I have some small query that when we talk about the micro scale in the 3D printing, right? So at in that case, when we make a CAD file, STL file, in that what level of pixel size we have to reduce?
In generally, if like I can, mm, for example, any 3D file you first created, either in
Hmm.
SolidWorks or Solid Edge or any other Inventor Fusion 360, you need to convert it into STL file. So at the time of exporting that particular 3D file into STL, during save option, you will find out options below the wherever we add the file name. So in option, you need to define what kind of linear and circular accuracy you require in STL part.
Okay.
If you provide us any one design in, for example, step file or any 3D format file, if you want to convert it into STL file, I can convert STL file with 100 MB also and 1 GB also. In 100 GB, you will find out rough file, STL file. And in 1 GB, you will find accurate. So there are in options, you will get like facility, how much linear accuracy is required and how much angular accuracy is required. And aside of it, there is one circle is changing. If you are changing accuracy, we all know like circle is made out of the linear lines only. How fine we
Yes, yes.
can like we can connect that particular straight line, we can get circle.
Right.
So
And is
we
that
can miss.
is
Sorry to interrupt. We printed 100 micron, 150 micron in electronics field, like electronic casing. If for locking purpose, there is 100 micron pin is required. We
so that
produce 20 mm, 30 mm deep hole with accurate accuracy.
so that is mostly when we switch on the micro scale 3D printing setup. So at that time, mostly it is more we rely on the liquid based raw material or
Yes, liquid base, mainly
initial
high
form. I am
accuracy.
talking about initial first. Am I right?
Yes, yes.
And the tool what we use, that is virtual tool rather than the nozzle base.
You can say light engine with higher DLP chip.
Okay.
Like whatever I am showing, D4K Pro is showed with jewelry aside in one slide. Okay, so 4K, if you have 4K technology and if you like, this is the projector only. How far you can put projector or how close you can get your build volume. There is
Okay.
direct correlation with the resolution of projector and how much distance you are putting with projection. If I am putting here, I will get smaller build volume. So my pixel resolution will be enhanced if I put my projector nearer to my
Near
projection.
Right, right. Near, if it is there, then that for cover area
Yeah,
will be the smaller one.
yeah. The
Okay.
build platform you will get smaller size, but accuracy
Yeah,
will be higher.
accuracy will be definitely higher, and then in that case, the beam energy level we have to go reduced.
Yes.
Okay. Participant, I think there is a red dot, so somebody has asked some question. Yes, Abhishek Kumar Gupta has asked. Number one is defect from lack of fusion in metal 3D printed parts, and second is often used in material in 3D printing. Jamin sir, you can check, I think, in chat box. So it will be convenient to answer it.
No, chat is not visible to
That is
me.
not visible. I think it will.
So what is the first question in metal printer?
Defect from lack of fusion in metal 3D printed parts. Defects from lack
Okay,
of
defects
fusion.
in uh, generally we can do various technology like X-ray, ultrasonic, ultrasound technologies are available, NDT techniques. Okay, but majorly 99% case there is no like porosity or infusion is happening in metal 3D printer. And like there are many make is available, like one of metal printer I showed you is desktop metal. Otherwise, other brands are available also. Okay, so
Okay.
like there may be like possibility of getting any defects with other technology. Like one is famous like from FDM like technology is available also. Italian based company. I doesn't recall name here, but available. So in that case, there will be some defects while printing.
Okay, next question is very, very generalized, but let us cover that also. Often used materials in 3D printing. Commonly, what are the material? What he is
What are
asking
the
that I
material?
think.
There are list of materials available. For example, if you require ABS like material in 3D printing, in liquid it is available. If you require castable material, which I showed WIC 100, you can search it out. You can search it out PIC 100. You can search it out high temperature. You can search it out rubber material also. So various applications, various material are available. Different makes are available. Okay, nowadays 3D printed, particularly if we talking about the DLP resins. So in jewelry field, there are manufacturer available in Vadodara only who are manufacturing jewelry resins and which are competing international markets also.
Okay, in case of jewelry, it is the metal. What mostly we use, maybe the gold or silver,
Yes, gold or
right?
silver.
But
Yes,
suppose microscale is there, commercial machines are available for metals. That is what, in which category of metals commercial micro machine 3D printers are available.
commercially it is available for aluminum and its
Okay,
alloy, assassin and alloy, titanium and that enable machine parts.
titanium alloys are is there available.
Yes, yes, available. Whatever like unmachinable materials are available that are processing.
Okay,
Nowadays, silver also used in metal 3D printing.
okay, thank
And gold
you.
also like one company is producing gold also. Gold jewelry also from metal.
Now, participant, is there any question? Okay, all questions has been answered by you. So now I would like to convey my thanks to Jaimin Bhatt sir. Thank you very much for inviting our sorry, accepting our invitation and spending your time with us. We know that in industry to get the time for such kind of activity is difficult sometimes, but you have managed your time. So thanks for that. And we are looking forward
Sure,
with
sure.
you
We are
for
also like
future
looking
collaboration.
forward for any collaboration if
Sure,
required with any academic
sure,
institute.
sure. Thank you very much, sir. Thank
Okay.
you.
Thank you so much.